Hey, what's up, Mr. Asada here. Today we're going to be going over the questions from part 2 of the final exam review. Let's get started. All right, so question 1, in physical science, a push or a pull is called is it force, acceleration, inertia, or motion? Correct answer is A, force. The definition of force in science is a push or a pull. So if something is a push or a pull, that is what we call a force. Right, question 2. The gravitational force between two objects is affected by is it motion and volume, B, motion and distance apart, C, mass and volume, or D, mass and distance apart? Right, the correct answer is D, mass and distance apart. The gravitational force between two objects is affected by their mass and their distance apart. The larger the mass of two objects, the greater the force of gravity, and the further away two objects are, the less the force of gravity becomes, right? So if two objects are really big and close together, it's a really strong gravitational pull. If two objects have very low mass and they're very far apart, that's a very low gravitational force. Right, question 3. In this picture below, the forces are the forces balanced, unbalanced, equal, or scalar? Right? The correct answer is unbalanced, right? So if the forces on an object are not equal to 0, then the object is said to be unbalanced. We can see there is an 80 Newton force pushing to the right and a smaller Newton force pushing to the left. So that's 80 to the right, 40 to the left. When we add them together, we get 40 left over to the right. Because number's not 0, it means it's going to push to the right, which means it's unbalanced. It's going to move to one direction. Right, for the diagram below represents a weightlifter holding a barbell above his head. The force of gravity pulling down on the barbell is 756 newtons. How newtons of force are exerted by the weightlifter to hold up the barbell? Is it 0 newtons, 378 newtons, C, 756 newtons, or D, 1,512 newtons? Right, the correct answer choice is C, 756 newtons. So here's my barbell. Here's my force of gravity pulling down on the barbell, 756 newtons. In order for the weightlifter to hold up the weight, he must supply 756 newtons upward to counter the force of gravity. Right, and that's the same thing there. So the weightlifter has to supply that upward force to counteract the downward force of gravity. If he did not supply a force at 756 newtons, if he did less, then the weight would fall down. If he did more, he would be throwing the weight in the air. Right, 5. The diagrams below show smooth blocks of wood being pushed against the same surface. The mass of the block and the amount of force applied are labeled in each diagram. In which diagram would the block have the greatest acceleration? Right, so we can see we have some different choices here. Some of them have different masses and some of them have different forces. Right, so which one is going to have the greatest acceleration, they want to know, given the force pushing on it and the mass of the block. Right, the correct answer is block number 2. This has to do with Newton's second law, F equals ma, force equals mass times acceleration. So the greater the force exerted on an object, the greater the acceleration, and the smaller the mass of an object, the more easily it is accelerated. So block 2, so you can see the largest force here is 20, right? So it's either got to be 2 or 4, and now we can see, so which one has a smaller mass now? Choice 2 has a smaller mass than choice 4, so it's got to be choice 2. It has the largest force with the smallest mass, so it means it will have the greatest acceleration of the blocks here. All right, question 6. Which object represents a simple machine? Is it A, the battery, B, the pliers, C, the match, or D, the candle? Right, the correct answer choice is B, pliers. So here's my pliers. Pliers are an example of a lever in which we have a fulcrum where the two parts of the pliers meet. The effort's getting pushed onto the lever on these sides, and the load will be carried in between the pliers. Again, pliers are an example of a simple machine with 2 lever arms and a fulcrum. All right, question 7. The diagram below shows a person using a simple machine to move a rock. What simple machine is the person using? Is he using a pulley, B, an inclined plane, C, a wheel and axle, or D, a lever? The correct answer choice is D, lever. A lever is a rigid bar that is free to move around a fixed point, a fulcrum. The fixed point is called a fulcrum, and the picture shows a man. He's using the board as his rigid bar, and he's using the box as the fulcrum. So he's using a lever. Right, and again, here we have an example. This is a basic lever. We have the fulcrum here, this little triangle. The rigid bar is this rectangular box here. And then when we push down on this side of the lever, then the other side of the lever goes upwards. All right, question 8. As a student runs a plastic comb through her hair, the comb acquires a negative electric charge. This charge results from the transfer of protons from the comb to her hair, protons from her hair to the comb, electrons from the comb to her hair, or D, electrons from her hair to the comb. Right, now this one, kind of confusing, but our correct answer choice is D, electrons from her hair to the comb. So as the comb is moved through the hair, electrons are picked up by the comb. Electrons have a negative charge, so when an object collects extra electrons, that object becomes negative. In this case, the comb has the extra electrons, so it becomes negative. Now remember, protons do not move. The only subatomic particles that are moving here out of our protons, neutrons, and electrons are the electrons. The electrons are the only ones that move, right? So we can eliminate A and B off the bat. That leaves us with C and D. So we know that the comb is going to be negative, so that's going to be the one that gained the electrons. So we know that the hair has to give up the electrons to the comb. So the answer is D, electrons from her hair to the comb. All right, question 9. The diagram below shows an experiment to test a certain property of liquids. What property of the liquid is being tested? Is it A, the density of the liquid, B, the magnetic attraction of the liquid, C, the conductivity of the liquid, or D, the freezing point of the liquid? Right, the correct answer choice is C, the conductivity of the liquid. In order for a material to carry a current, it must be a conductor. Engineers perform lots of tests for conductivity, which is the ability to conduct electricity when choosing material to build a circuit. This is a simple circuit on the left. If the light bulb turns on, it means the liquid is a conductor. So we can see we have two examples of liquids down here. This one, the light bulb doesn't turn on when the wire runs through it to the light bulb, so it's not a conductor. This one on the right, the wire runs through it. The wire runs into the liquid and then out of the liquid to the light bulb. It turns on, so it means it's a conductor. All right, last one, question 10. The diagrams below show the same two magnets placed in 4 different positions. The north and south poles are labeled. At which position will the force of attraction be the greatest between the two magnets? Is it choice 1, 2, 3, or 4? Right, the correct answer choice is 2, this one here, right? The opposite poles of the magnets attract each other, north and south attract. So right off the bat, they want to know which ones is going to have the greatest force of attraction. So right off the bat, we can eliminate 1 and 3 because north and north repel and south repel. So that leaves us with 2 or 4, north and south when they're close together, or north and south when they're far apart. Right? The magnetic force increases as two magnets move closer together. So at position 2, the force of attraction will be the greatest because the poles are opposite and they are close together. All right, that's going to wrap it up for review of the final exam part 2. This is the last video. So thanks for watching. If you have any questions, please let me know. Other than that, I know this has been a weird and probably not fun experience for most of you. So I really appreciate you sticking out with me. And I hope to see you guys in the fall. Please come visit. All right, bye.